I should also mention that these tides have specific names. Okay, for example, M2, we call the semi-diurnal lunar tide. O1 is the diurnal lunar, S2 we call the semi-diurnal solar, and K1 is the diurnal solar. Okay, so there are specific names, and they will pop up later on. So now before we talk about resonance features, what I want to do is talk about interference of. So you can have semi-diurnal tides created by the moon, and you have semi-diurnal tides created by the sun. What interference is, both signals sit on top of each other. At times, the signals amplify each other. Okay, they sit on top. You get a larger and amplified tidal range. At other times, the signals cancel out each other. Okay, partially cancel out each other. And this is what we call the spring-neap tide cycle. Spring and neap tide cycle. And there's a little attempt here to show you an animation. Okay, it's only to do with the situation. Whenever you have the sun and the moon and the earth in one line, you get the spring tide. You get an amplified signal. And whenever you have the situation of having a half moon, you get the neap tides. And let's see whether that animation still works. Get spring tide, neap tide, spring tide, neap tide. Okay, and this is what you can see if you measure tidal sea elevation. So this is one for Liverpool, is one example. You can see the moon's phases and so on. You can see, and sometimes this is the sea level elevation. You can see the spring tide and the neap tide. And hereby it's important to mention that spring has nothing to do with the season spring. It's nothing to do with the seasonal. These tides repeat all the time, and you always have vary between neap tides and spring tide. Okay, so this is called interference. Okay, so tides or tidal constituents happen at the same time, and they interfere with each other, the signals. Here in South Australian Gulfs, we have a situation where the neap tide leads to almost vanishing tides. It's called the Dodge tide. Okay, so you have actually two tidal constituents which almost perfectly cancel out each other, the so-called Dodge tide.